Hi, welcome to Numeration Systems. So first, what is a numeral compared to a number? A number is a concept. Everyone around the world can talk about two-ness or three-ness as how many objects are there, but we don't agree always on how to write down that concept. So how we write it down is called a numeral. And so my favorite way to explain is to talk about how 42,897,123 is a really big number, right? A lot of stuff. But I have written down here a really big numeral because the numeral is what we write, not how much something is. And so every numeration system consists of these numerals, these symbols. And so you're going to notice when we talk about numeration systems of different cultures that some systems have a symbol for zero, some don't. They have different symbols. And another thing you'll notice is that in some systems, changing the position of the symbols changes the value of the number it represents, but not always. If changing the position of the symbols matters, we call this a positional system, and what position it is its particular place value. So in base systems, we are going to use the symbols from 0 to 9, but only the ones less than whatever base we choose. So if I'm in base 3, I'm only going to use the numbers 0, 1, and 2. And the place values are always given in terms of the base. The rightmost one is always going to be the ones place. And then if I go to the place to its left, I multiply by the base. To get to the one to its left, I multiply by the base again. So our normal everyday system in base 10, we have the ones place in the far right. If I look to the place to the left of it, it tells me how many tens. If I look to the place in the left of that, it's how many 10 times tens, or hundreds. And then the place even to the left of that, it'd be 10 times 10 times 10. That'd be the thousands place, and so on. Now in the other way, if we use, say, base 3, the allowable symbols are only 1, 2, and sorry, I'm back. So base 3, we can use a 0, a 1, or a 2 in each place. The rightmost place has to be the ones place. I multiply 1 by 3. That tells me the position to the left of the ones is the 3s. Multiply by 3 again. That tells me the third place from the right has place value 9. And then the one to the left of that, I multiply by 3. That tells me how many 27s I'm going to use. And so I have a question that you should look at before you move on. What are the 6 smallest place values in base 5, and what are the allowable symbols we can put in each place? Okay, you should have stopped this presentation and found the answers. And here are the places, although they're in the reverse order. The rightmost one is 1. The next to the rightmost is 5. The next one, that is the third one over, starting from the right, is 25. The one to the left of that is 125. The one to the left of that is 625. And finally, the leftmost one that we were going to write is 3,125. And we're only allowed to use symbols 0, 1, 2, 3, and 4. So in base 10, the number represents 123, 1 100, plus 2 tens, plus 3 ones. Because, well, 3 is in the ones place, 2's in the tens, and 1's in the hundreds. But if I write 1, 2, 3 base 5, it means 3 ones plus 2 5's plus 1 5 times 5. That adds up to 36. Notice that I did not call it 123. That's because that 1 is not in the hundreds place, it's in the 25's place. So we just say the name of the digit in the place and not use base 10 numbers like hundreds and thousands and so on. All right, here's some practice problems. You should stop and do them. And on the next page, there is going to be some answers, and you should also stop the presentation and check your answers as well. So our numeration system is called the Hindu-Arabic system because it started with the Hindus and was brought to the Arabic world and brought to Europe in the 1200s by a guy named Fibonacci. So our symbols are 0 through 9, and we do have place values, and our base is 10. So let's look at some other cultures. The Egyptians did not have place value. So their symbols represented numbers. You can see the ones to the right, 1, 10, 100, and 1,000, all the way up to 1 million and the astonished man. And all they did was to write. They just took for each place what the symbols were and drew as many of them as they needed. So we have 435, it's 4 hundreds and 3 tens and 5 ones. I could have just as easily written that horizontally and put the 400s first and then the 3 tens and then the 5 ones. It kind of mattered to the Egyptians whether they could fit it onto that piece of paper or tablet or stone wall. And so over time, the way they wrote them as far as organizing the numbers changed. The Egyptians also did not have a base system, but they did use tens and hundreds in their symbols. And notice that the Egyptians didn't need a 0, and neither did the Romans, because they didn't have to hold places with zeros. So there are certain rules for Roman numerals. You're not allowed to use more than 3 of any symbol in a row. And really, you could only use certain ones for that, like the ones like 1 and 10 and 100 and thousands. If the value of the symbol went up from one symbol to the one on its right, you subtract. And you can see in number 3, those are the only subtractions we're allowed. Notice they all have something to do with 4s or 9s, 40s, 90s, 400s, 900s. And if you wanted to write a really big number, you could take the part that was in the thousands once it was past 3,000 and just write the number of thousands and put a bar over the top. You can use a double bar if you want to get numbers over 1,000,000, but I think those are awfully big for us. So you can see there's some practice. So 4,984. Since I'm past 3,000, I draw the number 4 and then put a bar over it to make 4,000. 900 would be 1,000 take away 100. That's CM. 80 would be 50 plus 60, 70, 80. So 50 plus 10 plus 10 plus 10, and then 4 is IV. So here's some more problems for you to try, and we should put the answers in the next slide.